In these next few groups of questions, we're working with imaginary numbers. So 13 through 16, we're just supposed to simplify. Now what we do is we remember our little key here. So make sure you know these four things. And then as we work through here, what we want to do with each one is we want to find a multiple of 4 less than the exponent, but as big as we want, but less than the exponent. And because I to the 4th, and really any multiple of 4 gives us 1. So here, I to the 31st, we would change to I to the 28th because that's the highest multiple of 4 without going over 28. And then what's left over, 31 minus 28 is 3. And so the multiple of 4 is just 1. And then I cubed, we know have our key here is negative I, so 1 times negative I is negative I. Over to number 14, we want the highest multiple of 4 without going over 98. So what I do is I remember that 4 definitely goes into 100. And so from 100, I subtract 4, and I know that I will go into 90, or 4 goes into 96. 98 minus 96 is 2. And so I to the 96th is 1, and I squared, we know from our key over here, is negative 1. And so 1 times negative 1 is negative 1. 15 and 16 both have large numbers, but the nice thing is we actually only have to be concerned with the number formed by the last 2 digits. And so we can just think of this as I to the 44th. And 4 actually goes into 44. 44 is a multiple of 4, so this is just equal to 1. Once again, we can look at just 53. And I to the 53. Highest multiple of 4, I think, is 52, because 48 is a multiple of 4, then add 4, 52. So we can say this is I to the 52. 53 minus 52 is 1. I to the 52 is just 1, because any I to a multiple of 4 is 1. And I to the first is just I. So number 16 is just I. For 17 and 18, we have to find the absolute value. Now we do have a little formula that says the absolute value of any complex number is always equal to the square root of a squared plus b squared. Notice we do not have an I in here. We just do the a and the b. B could be negative, although in this case it doesn't matter that much. Now, this formula always works, and we'll use it for number 18. But if we take the absolute value of what we call a pure imaginary number, the answer is just going to be the absolute value of this number, which is 4. On number 18, we will use this formula. So this A is 6 and B is negative 8. So we can do the square root of 6 squared plus negative 8 squared. Please remember that a negative squared is actually a positive. So this is the square root of 100, which we know is 10. So the absolute value for number 18 is 10. And then for 19 and 20, graph each number in the complex plane. So what we'll do is we'll draw a complex plane. So we have, I always draw my vertical first for some reason, but here we have our real axis and then the imaginary axis. Sometimes we just put a lowercase I. So on our real axis, this is 1, 2, 3, 4, 5, -1, -2, -3, -4. We have I, 2i, 3i, 4i, and -I, -2i, -3i, and -4i. Now that we have that drawn, I'm going to zoom out a little bit. We'll do this first one in orange. This is -4 minus I. That means we go to -4 on the real axis and then down to -I, so down 1. And this orange dot here represents -4 minus I. I'll just use the same plane for the next one. We'll use this color blue. This one tells us we go to the right 3 and then down 4. So 3 minus 4i is right there. And that is the imaginary number. We also learned operations with imaginary numbers. I don't have any addition or subtraction here. If we did, it's just adding or subtracting like terms. For 21 and 22, we multiply. Now, we did learn a nice pattern when we square a binomial. It's the first term squared. So -6 squared is 36, plus the first times the second times 2. Well, -6 times -4i is 24i, but then we double it, so it's 48i. And then the last thing we do is square this one. Well, -4i squared. A negative squared is 16, so 16i squared. However, we remember I squared is -1. And so we have 36 plus 48i minus 16, because we do 16 times that -1. Adding like terms, we get 20 plus 48i. Number 22, we just distribute, maybe use the idea of FOIL. So this is 6 plus 18i plus 2i plus 6i squared. Well, remember, this is -1, so really this last term is -6. So we have 6 plus 20i, adding those two like terms, minus 6. So a 6 and a -6, we just get 20i.